Welcome to Bullets and Brass. Today we are going to be talking about another fundamental aspect of shooting, for lack of a better term, the cartridge itself. And I'm going to be putting still frames up because when I tried to shoot this video the first time, me showing you these and trying to get comparisons between them really didn't work. I kept having to hold it right up to the camera. You couldn't see it. Waste of time. So cartridges have basically four main components. There is the actual case, the brass case, the bullet that actually leaves the gun and travels down the barrel. This is the part that actually impacts the target. The case might leave the gun, but it's leaving it by the ejection port. The primer, which I don't have here, they're little tiny cups basically. I'll put a picture. I'll put a pic. I was going to try to tip one of these up and show you, but yeah, that doesn't help you, does it? And then the powder. Now, the primer and the powder are the part that do the work physically in the gun. They are the parts that generate the energy. The primer is just enough to get the powder going, and the powder then burns rapidly. It does not explode. It burns very rapidly. And exploding is actually a legal definition for beyond a certain rate of combustion. So powder does not explode, gunpowder. It burns very rapidly though, and creates a very large amount of hot gas that is expanding and pushes the bullet down the barrel. So that is how the round actually fires. Now, you have different size cases. You have rifle cases, you have pistol cases, you have things that are used in both. You have many different kinds of bullets. Now, one of the critical things is that your bullet is a particular diameter. That is the caliber. So 30 caliber is 0.3 inches across. 22 caliber, 0.22 across. But that doesn't mean that they're all the same. For example, this is a 30 caliber case, 30-30. This is a 30 caliber case, 308. These do not use the same bullet. They're both theoretically 30 caliber. The bullets are not actually the same diameter. They're close, not quite. You would not want to mix and put the wrong one down the wrong barrel. You also have aspects of the length of the case versus the caliber. So for example, 7.62 by 51, commonly called the 308 in the US, the case is 51 millimeters long. Now that gives you a powder capacity of X. Because this is designed, sorry, let me continue. This was designed for smokeless powder. Smokeless powder varies tremendously in the amount of energy generated. You can have powder that fills that case and creates very little energy, relatively speaking, or if you filled that case with it, you would probably destroy the firearm. 30-30 was designed for black powder. The 30 is how many grains of black powder of the common type used fits in the case in the normal cartridge, normal round. So you're putting a 30 caliber bullet of the right type, not just 30, in there, and you got a certain amount of room for powder. That is what the 30 on this stands for. You'll also hear 45-70 is a common round called that way. You'll hear 223 referred to as 5.56 by 45. Keep in mind there are differences. I'm not going to get into that whole debate right now, but 223 Remington is the parent cartridge for 5.56 by 45. However, a rifle designed for 223 may not be happy with 5.56. Match your round to what the rifle was intended for. Now powder's fun. powder is literally just grains of powder. We're going to put most of this back. Close this. Move that safely out of the way. Get a long match. I'm going to move this out here. This is what powder does when not contained in the case, in the chamber of a gun. Ready? Now, it was dramatic. It flares up nicely. It burns reasonably quickly. But certainly, if a cartridge took that long to burn, it wouldn't be very effective, would it? You'd have all the time in the world to dodge. You could be like, poked and move the barrel out of the way. It wouldn't work. When that's contained in a cartridge and is under pressure and is lit by a primer, which is much more energetic than this match, it burns much more rapidly. In doing so, it propels the bullet forward. So this was a particularly fast powder, actually. This was Hodgkin's Clays, which is a shotgun powder that is considered one of the faster powders on the market. If I had used a Magnum powder or a large rifle powder, they burn very slowly in comparison. And that same amount of powder would have taken much longer to flare. It would have been harder to light and a longer, not only harder to light in the sense that it would have taken more effort, but it would have been, put the match there and it would start burning and then slowly grow and burn. So you got to match the powder to the task. Now we're not going to get into reloading in this video, just consider that there are differences. This is not a one-size-fits-all kind of thing. There are entire libraries, I was going to say books, but there's basically libraries full of data and research on this subject. Lots of very smart people do a lot of research to come up with new powders and formulas. So that is how a cartridge works. That's how you get a bullet leaving the barrel fast enough to do some work. Hopefully that was entertaining with the powder. I realized that otherwise it's a pretty dry subject. It really is not the most interesting on its own. It really becomes interesting when you start applying the differences and what they really mean in end results. Because different cartridges have different speeds for different bullets. They can do different things. This video is going to lead into another video discussing relative power and what it really means, because there's a lot of confusion. So that is it. Thank you for watching. Have fun, take care, and stay safe all.